You have zoomed in. Excellent. What's going on? This is the pressure volume diagram, the PV diagram, and it shows how much work, or indicates how much work can be delivered by the gas inside the engine. There's a horizontal line here, and that represents the atmospheric pressure for an atmospheric engine, or the pressurization, pre-pressurization level for a pressurized engine. And clearly the outward stroke, I've got conrod in compression, the conrod is being pushed out by the expansion of the gas. But when that line goes below the atmospheric pressure, the momentum of the piston is pushing the piston and the mechanism to reach bottom dead center at the extreme right. With the pressure now partial vacuum inside the engine, the exterior atmospheric pressure pushes the piston in. The gas is contracting. And then when we get to the atmospheric pressure level again, the momentum of the piston pushes the mechanism up towards TDC, top dead center. So I call this the one-stroke engine because the expansion stroke pushes the piston, and when the gas is below the reference pressure or atmospheric pressure, it is pushed inward on the contraction stroke. The gas is contracting. Here are the real measurements of pressure and volume on the engine that you saw previously, running without a flywheel. Yes, the red line across the diagram is the level of atmospheric pressure, or the buffer reference pressure. And yes, the momentum of the piston drives the mechanism through to bottom dead center, the extreme right of the banana or loop. And then as soon as it passes over that point of bottom dead center, the atmospheric pressure is pushing the piston back on its inward journey. And then the piston, the momentum of the piston, can compress the gas so to reach the maximum pressure of the stroke. But the net situation is that the expansion stroke is a power stroke, and the contraction of the gas is also a power stroke.